Picture a radioactive source. Next to the source is a sensor which detects a radioactive emission. Attached to the sensor is a toxic gas, and sat next to all of this is our cat. At some point in the future, the radioactive source will emit a subatomic particle. We can't determine when this will occur, even if we know everything about the source. When the sensor detects the particle, it releases the toxic gas, and the cat is killed. Imagine we put this whole setup in a box, Schrodinger's box. We genuinely don't know the state of the cat until we open the box. It might be alive, it might be dead, but we can't possibly know until we make some form of observation into the box. The point is that there is inherent uncertainty in the universe, and that even with all this information, this uncertainty remains. Essentially, we can say the cat is both alive and dead in a state of superposition. Its state only becomes determined when we open the box and observe it. Let's take this up a notch. Let's say we have a safe, and inside the safe is a cure for cancer, or an amazing chemical process, or something else of significance. Alas, the safe is locked with a combination, and we don't have the key. One way of opening the safe is to go through every possible combination, but this could take years if the combination is long enough. Imagine we were able to put the safe in our box. Inside the box, the safe is 2 in a range of states, just like our cat. The probability the safe is in the same state it went in as is very high, but there are also small chances, due to the uncertainty in the universe, that it could be in different states, potentially with different combinations. Now imagine we are able to manipulate the states within the box, without actually observing what is inside. Imagine we can change the probabilities in our favour, such that it's more likely that when we open the box, the correct combination is revealed. Rather than having to brute force every combination, we've manipulated the probabilities of subatomic particles, so they've essentially done this process in a single step. Now, of course, we're not really putting safes in boxes, but the principle is similar. In quantum computing, we use subatomic particles that have states of 0 or 1 when observed, but until they're observed, they're in a state of superposition of both. This superposition is a bit like the cat being both alive and dead in the box. We can perform operations on this superposition by firing lasers or magnetic fields, which allow us to build algorithms. When we open the box, we observe the output of our manipulations. The crucial point is we can solve problems far, far quicker using this approach than using the brute force method. The problem today is that we can't hold enough data in a quantum computer that we can solve a problem quicker than a traditional computer. The subatomic particles interact with each other and cause errors. But as the technology matures, quantum computers will be able to process more combinations at once, giving a huge speed up compared to traditional computers, literally solving problems in hours that might have taken millennia before. But this is at least a decade away yet. But then again, it is worth experimenting now. Many vendors are offering free access to development platforms, and there's little to lose by playing around and being aware of the possibilities. If you have a problem in mind that promises a big return, it's worth engaging with vendors now.